Okay, here we have some examples of perfect squares. What you will notice is that what makes it a perfect square is that this number at the end here is always half the middle number squared. So half of 8 is 4 and square that is 16. Half of 6 is 3 and square that is 9. And half of 4 is 2 and square that is 4. So what these look like when factorised is... and you'll notice also that the number that goes into the factorise is also half of that original middle number. And half of 6 gives us the 3 and half of 4 gives us the 2. So these are our perfect squares, and they are the basis of where completing the square comes from. So if we move down to completing the square, we might be given an equation that looks something like this: x squared plus 8x plus 5. And we can see that half of 8 squared does not equal 5. So what we are thinking is the perfect square would have been 8x plus 16, and that would have factorised to x plus 4 squared. So our magic number is 16, and the formula for that is half of the b squared, so half of 8 squared. So in our working out, we're going to rewrite the equation. So we get x squared plus 8x. And this is where we want to add 16 so that we have a perfect square and we still have a plus 5. Now, if we add 16 to an equation, that would make it just unbalanced. We can't just randomly add 16. So we need to take 16 at the end there. And what we get is a perfect square and this extra bit at the end. So when we factorise our perfect square, half of 8 is 4. So that will be x plus 4 squared. And plus 5, take 16 gives us minus 11. So we have a perfect square and an extra bit, and that is all done now. Okay, one more example. So in this one we have x squared plus 6x plus 3, not a perfect square. So half of 6 squared is 9, so that's our special number. We'll need to take away 9 to keep our equation balanced. And we'll end up with this perfect square here and this extra bit at the end. The perfect square, half of 6 is 3. So that factorises to that. And plus 3, take 9 gives us negative 6. And that one's done. Okay, so factorising after we've completed the square, or if you've been given an equation in turning point form, just like completing the square, we sort of need to play around with it. And what we want is for the second thing to be in the form of a number squared. So that bit's staying the same. Now a 5 is the same as the square root of 5 squared. And what that's allowed us to do is have something squared take away something else squared, and we can actually use the difference of perfect squares now. So our a is x take 3 and our b is square root 5. And so now we're going to write a plus b and a take b. So our a plus our b and our a take the b. And to solve this, if this was to equal 0, we would then use the null factor law, which is that the first part will equal 0. Which will rearrange to 3 take root 5. And the second and there are our two solutions. And the way to work that out without completing the square and using this way, it would be to use the quadratic formula. but if you've been asked to factorise, you'll have to do it this way. Now, just looking at the one I had written up here, because we've got this plus here, difference of perfect squares isn't going to work. And if we actually made this equation equal 0, the first step we would get would be x take 2 squared equals -6. And then we would be finding the square root of both sides, and that would be the square root of a negative number, which means we have no real solutions. So when you have the plus there, you can't actually factorise into DOPS or solve that one.